Alrighty, students, so we are jumping back into our lesson. So today we've been talking about thermal energy transfer. Now I know you've done some task cards where you tried to match up what you thought the type of thermal energy transfer was, and you've also done a really fun science experiment where you melted an ice cube using these forms of thermal energy transfer. But one thing we haven't done yet is talk about what these things mean. So I know you have heard a lot of fancy words being thrown around today, and you've heard words like thermal energy, you've heard words like conduction and convection and even radiation. Now, some of these words are big and they can be a little bit intimidating, especially if you don't know what they mean. So what I want to do right now is I want us to think about what these words actually mean. So when you hear the word thermal energy, what does that mean to you? What do you think it means? Think about the words. Thermal energy. I'm going to give you a second. Okay, so after giving you guys a few seconds, I'm going to go ahead and maybe try and guide your thinking a little bit. So the word thermal is often associated with heat, but I wonder, can cold things have thermal energy? I want you to think on that for a second too. Okay, so the short answer to this question is yes. Even things that are cold, like a cold water bottle, can have thermal energy. So, when we think about thermal energy and we come up with our definitions of what it is, what do we think about it when it means thermal energy transfer? Think about that for a second. Okay, so like I said a few minutes ago, thermal is often associated with heat. Now, thermal energy is a type of heat that's made when molecules move. So so just think about it like this. Everything has molecules. So when those molecules get to moving, think about like rubbing your hands together and there's this friction. What starts to happen to your hands? Do they get cold or do they get hot? Try it out. I'm sure some of you observed that they actually get a little warm. Now, I know that that can be confusing because you're like, well, I thought you said that cold things can have it too. They can. And that'll get explained in another lesson. But, so we've talked about thermal energy, we've talked about what that kind of means, but when you think about thermal energy transfer, that's a little bit self-explanatory, don't you think? So if we know what thermal energy means and we know what transfer means, then we should know what thermal energy transfer means, right? So if we've associated thermal with heat, and we know that transferring something means you move it, we're basically, when we think about the words thermal energy transfer, it just means how energy moves. Now, heat energy specifically can move in 3 different ways. And we've heard those words a lot today, and we're going to go over them. So there's conduction, convection, and also radiation. So say those with me. Conduction, convection, and radiation. Now, the first one we're going to jump into is conduction. So conduction is the transfer of heat from one object to another. So think about that for a sec. What do you think that means? Without looking at the example, what do you think that means? Okay, now one example that I used on here is if you were to light a match, that match puts off light, that match puts off heat, and the match is very hot, so don't touch it. But if we were to take that match and put a metal spoon over the top of it, which we learned metal spoons are conductors, if we put that metal spoon over the top of it, what do we think would start to happen? It would probably start to heat up, right? So that is what conduction means. So conduction is the transfer of heat from one object to another. But can conduction happen in liquids or gases? Think about that. Now, I'm not really sure about that, but I know that conduction occurs most commonly in solids. And then some other examples just to help you kind of understand about what conduction is. So how many of your parents when they start the car and they've been driving in it for a while and you're driving to the mall and you get to the mall, the engine's kind of hot. The car's putting off a lot of heat, right? So conduction is an example of that is basically the engine in the car getting hot because it's been running for so long. And then another example now, raise your hand if you've ever gone camping. Or actually, raise your hand if you've ever cooked hot dogs on a fire. With you got your little stick and you found it in the woods and you put your hot dog on it and you toast it over the fire. How many of you have done that before? Okay, awesome. So, conduction, an example of that in this is the heat transfer from the fire to the hot dog weenie, right? So the hot dog weenie is not just going to stay cold if we put it over the fire. It's going to absorb that heat. And then one more example that I'm going to give you guys is, I don't know if you guys are hot cocoa drinkers or warm tea drinkers, or even if some of you are hot coffee drinkers. But I know that when I make myself a cup of coffee in the morning and I pull it out of the pot and I pour it into my mug will start to heat up because the hot coffee acts as a conductor to the mug. So the mug starts to get warm, and that's an example of that. And so moving on to our second form of heat energy transfer, thermal energy transfer, is convection. Now, convection is a transfer of heat that's often seen in liquids and gases. It's seen in what? Liquids and gases. Now, one way that I like to think of this is it's kind of like the circulation of air, of molecules within a liquid or a gas. So how many of you have ever heard the saying, hot air rises and cold air sinks? Yes, no, maybe so. Well, I've actually experienced this before. So I remember one time I went camping and we camped in like an RV. So my dad had rented an RV for the weekend and we camped in it and I slept in the top bunk. Now the top bunk was so hot and I realized, I've heard this before, hot air rises, so maybe that's why I am so hot and I should try to get my brother to switch with me so I can be cool. But an example of this, if you're not familiar with that, is when your mom puts a pot of water on the stove and she starts to boil it, you'll notice that the water inside of the pot starts to get really hot. Now I know that this can be a little confusing because you're like, well, isn't that similar to conduction? Like the water's getting hot from the fire. But when you think about it, the pot is actually getting hot from the fire, not the water. And the water is getting hot because of the molecules that are moving within it. Does that make sense? Yes, no, maybe so. Okay, another example that I like to use when I think of convection is, how many of you have ever seen a hot air balloon? In movies, and on TV, in person. How many of you have ever been in a hot air balloon? That's pretty cool. I've never been in one. So the way the hot air balloon works is, if you haven't ever been in it or seen it, there's this little basket, and inside the little basket there's a flame, and they light it, and it's a really, really big flame, and it's super loud, and you can hear it going off. Basically what it does is it shoots heat up into the top of the little air balloon, right? And what that does is it creates an air current. And the air current, the heat rises, and it has so much strength that it makes the basket that you're standing in float up, and that's how you get to fly up in the sky and venture and all kinds of stuff like that. So that's pretty fun. So we've reviewed our first form of thermal energy transfer, which is conduction. And we've just reviewed our second form of thermal energy transfer, which is convection. And now we're going to move on to our third form of thermal energy transfer, which is radiation. So radiation is a little bit different from convection and conduction in that you don't have to touch it to feel it. So I'll go ahead and read the definition for you and then I'll jump into an example. So radiation is different from other forms of heat transfer in that it doesn't need any other materials to occur. So radiation travels by waves that we can't see. So I know that it's common to think of waves as like the ocean, but that is not this kind of wave. So the main example that I think you guys are going to understand most is like when it's summertime and you're walking from your house to your car, or your house just to go outside and play, which all of you should be doing, by the way. When you walk outside and the sun is beaming down on you and you start to sweat and you get so hot and you get a sunburn. How many of you ever gotten a sunburn? I have had plenty of sunburns in my life. But that is caused by the radiation of the sun. Now, I know what you're thinking, how is this possible if I'm not even touching the sun? I'm not touching it, so how is it hurting me? How's it burning me? Why is my skin red after I go out in the sun for so long? Well, that's because the sun is so powerful and so hot that it sends waves of radiation into the world. And those radiation waves are so strong that we can feel them. Now, another example, if you somehow have never experienced this before, is when you have a campfire. How many of you have gone camping? We're going back to the camping. If you've ever gone camping, raise your hand. If you've ever been around a fire, raise your hand. I know I have. And so when I'm standing next to the fire, I know that my body is not cold. Actually, I'm normally really, really hot. But it's so interesting because how am I hot if I'm not touching the fire? Well, the fire is another strong form of heat that causes radiation waves. So basically, when you're around something that's really strong and hot, that heat kind of projects, and you don't even need to touch it to feel the heat from it. And those are called radiation waves. Now, we've talked about the first form of thermal energy transfer, which is, say it with me, conduction. And we've talked about the second form of thermal energy transfer, which is convection. And we've just completed talking about our third form of thermal energy transfer, which is radiation. So if you guys have any questions, don't be afraid to reach out to me. Thank you so much for listening. Bye-bye.